Okay. Proportions. Let's start out by defining a proportion. A proportion, by definition, right? A proportion, by definition, is two equal ratios. Two equal ratios. Now, sometimes using words in there that we don't really know, like ratio, is difficult. So if I look back at yesterday or 2 days ago, a ratio is a comparison of two different quantities. 21 or 27 over 1. What's another word for the way this is written right here? A fraction. A ratio is actually just a fancy word for fraction. A proportion is two equal ratios or two equal fractions. For example, 1/2 and 5/10 are a proportion. How do you know that these two are equal? They look different. How do you know if these two are equal? Haley? Right. If I simplified this, you'd get 1/2. 2 times 5 is 10. 1 times 5 is 5. It increases by the same amount. So yeah, they're equal. Or another example is 4/6 is equal to 8/12. But how do you know? How do I know that those two are equal? Safi, how do you know? Yeah, I multiply both by 2. Or 4/6 simplified is 2/3, right? And 8/12 simplified is 2/3. They're equal. They're the same. I know that they are a proportion. But do you think it's always going to be that easy? No. We're going to use something today called cross products. And again, we talk about this quite a bit in math class. Mathematicians are not creative people. Cross means across from each other, and product means multiply. We're going to multiply the diagonals, or across. This right here, we're looking for the multiplication or the multiplication property of equality. When we multiply the diagonals, we're looking for the multiplication property of equality. We're going to use cross products with math. That's as easy as it gets. We cross product, multiply the diagonals. And what we're looking for is the multiplication property of equality. What do you think this means? The multiplication property of equality. What do you think equality means? Equal. If we multiply, we're looking to see if they're equal. Multiplication property of equality. Multiplying to see if they're equal. Again, multiply the diagonals, cross product. Because if I show you this this proportion, 7 over 12 and 17.5 over 30. I don't know. Maybe. So we're going to cross products, multiply the diagonals. So what does that mean? Haley, what's one of them? 7 times 30. And what is 7 times 30? 210. Good. Then what else am I going to do? Skylar? 12 times 17.5. Could I do 17.5 times 12? It doesn't matter because it's multiplying, right? Do you remember what property that is? Perfect. The commutative property of multiplication tells me it doesn't matter which way I multiply. And what is 12 times 17.5? 210, isn't it? So are these equal fractions? Yes. So we'd put our answer as an equal sign. And how do I know that they're equal? I used cross products. I multiplied the diagonals. And the multiplication property of equality, since they're the same, they're equal. Let's do another one. 15 over 20 equals 5 over 7. Is that true? Let's test it out. What can I multiply first? 15 times 7. Or could I do 20 times 5 first? Doesn't matter. 15 times 7. What is 15 times 7? 105. 20 times 5, or 5 times 20, it doesn't matter. 100. So are these equal? Is this a proportion? No, so I'm going to put a not equal sign. This one didn't work. Those are not proportional. 5 out of 20 is not the same, or 15 out of 20 is not the same as 5 out of 7. If you had a pizza and cut it into 20 pieces and ate 15, and somebody else had a pizza and they cut it into 70 pieces and ate 5, you would not have had the same amount of pizza. Right? They are not proportional. Let's write the algebra of this. If your first fraction was a over b, and your second fraction was c over d, what would you do? You're going to multiply what times what? You're going to multiply a times d, whatever those numbers are. What else are you going to do? B times c. And if they're equal, it's a proportion. If they're not equal, it's not a proportion. Okay, so that seems pretty easy, right? Let's try this. We're going to do the same thing. We're going to do cross products. So who can tell me? What's my first one? What am I going to do? X times 6. What is X times 6? 6X. Good. I like how you flipped it around. What's my next one? 9 times 4. And ladies and gentlemen, you can skip this step of writing out the math problem. You can do that mentally, but in our notes, we want to write it down so you remember if you need it. What is 9 times 4? 36. I wonder what we would do. I wonder what we should do. Hint, hint. Equation. Gavin, what are you going to do? Not distribute. You're close. What are you going to do to get X alone? Good. Inverse operations. Divide by 6. X equals what? 6. Let's try another one. 22 over D is equal to 6 over 21. What do we do first? Could I do 22 times 21? (22 times 21). What? 462. D times 6. What is D times 6? 6D. What do I do? Find out what D is, so I divide by 6, because that's the inverse or the opposite. What's my solution? I love how I heard someone say D equals 77. How come we put D first? We always want to try to put our variable first. Is 77 equals D an appropriate answer? Yes, it's just not the best. Let's try one last one. 4.2 over 10 equals 8 over X. Cross product. What's my first cross product? 4.2 over X. Did anyone do 10 times 8 first? It's okay if you did. It doesn't matter. 4.2 times X equals 4.2X. 10 times 8 equals 80. Last but not least is divide 4.2, inverse operations. You're going to have to round. Let's do the nearest hundredth. 19 5/100. Ladies and gentlemen, this time though, I should not put an equal sign here. I should not say X equals 19 5/100. What should I do to that equal sign? Not draw a line through it. That means that's not the answer. This is the answer, but what did I do? I rounded. What do you do when you have to round? Cat? I make them a little bit squiggly. That tells me that I rounded a little bit. So if you go back and check your answer, it might not work exactly since I had to round. All right, one more. Let's write down this word problem. Yes, you need to write it all. A microchip inspector found 3 defective chips in a batch of 750 chips. At this rate, how many defective chips would be in 10,000 chips? A microchip inspector found 3 defective chips in a batch of 750 chips. At this rate, how many defective chips would be in 10,000 chips? Here's the clue, ladies and gentlemen. What 2 numbers are in the same sentence? 3 defective chips and 750 chips. If they're in the same sentence, they go in the same fraction. 3 defective chips, 750 chips. If they're in the same sentence, they go in the same fraction. But there's a third number in our story problem. What's my third number in my story problem? Jesus? Where do you think 10,000 chips is going to go? If I'm making a proportion, Safi, where do you think? Well, I don't know how many are going to be defective, so I need to figure it out, right? So I'm going to put 10,000 chips on bottom, because they're the same label. I'm not changing anything. I don't want them diagonal to cancel out. I want the same label on the same line. So could you figure out what number goes up here? Doing exactly what we did up here. Can you find this missing number? What do you think you're going to do first? Safi, what do you do first? Cross product. 3 times 10,000, and I ran out of room, so I have to write it over here. 3 times 10,000 is 30,000. So what's my other cross product? 750 times x. What is 750 times x? 750x. And what's my last step in a proportion? What? I'm going to divide by 750. So how many defective chips would there be in 10,000? If there are 3 for 750, how many in 10,000? How many? 40 defective chips. Cross product, that's the key to tonight's homework. Multiply the diagonals. Sometimes it tells you it's equal or it's not equal. Sometimes you have to solve for the missing number. If the numbers are in the same sentence, they go in the same fraction.